The universe, as we experience it, appears to be composed of things. We see rocks, trees, planets, stars. We hold objects in our hands. We move through what seems like empty space from one location to another. This perception runs so deep in human consciousness that it forms the foundation of how we think about reality itself. Yet one of the most profound insights to emerge from fundamental physics is that this intuition, this sense that the cosmos is built from distinct objects occupying positions in space, may be fundamentally mistaken. The universe, at its deepest level, is not made of things at all. To understand this claim requires us to reconsider what we mean when we talk about an object, about matter, about the stuff of existence. In everyday language, when we say something is real, we typically mean it has definite properties, that it exists in a particular place, that it persists through time with some continuity of identity. A chair is a thing. It has a location. It has mass and shape. Tomorrow, we expect it to still be a chair, in roughly the same place, made of the same wood or metal or plastic. This picture of reality as a collection of persistent objects with definite properties feels so natural that questioning it seems almost absurd. But physics, particularly as it has developed over the past century, tells a different story. The first hints that something was wrong with our intuitive picture came from quantum mechanics, which revealed that the fundamental constituents of matter do not behave like tiny versions of the objects we encounter in daily life. An electron, for instance, does not have a definite position until we measure it. Before measurement, it exists in what physicists call a superposition, a strange state where it is, in some sense, in many places at once. This is not merely a limitation of our knowledge. It is not that the electron has a definite position that we simply do not know. Rather, the electron genuinely does not possess a definite position prior to measurement. The property of location, which seems so essential to our concept of a thing, is simply not there. This represents a radical departure from classical thinking. In the older Newtonian picture of the world, everything had a definite position and a definite velocity at every moment, whether we knew these values or not. Reality was like a vast machine with each part in a specific state, evolving according to deterministic laws. Quantum mechanics shattered this picture entirely. Properties like position and momentum are not pre-existing features of particles waiting to be discovered. They come into being through the act of measurement itself, through the interaction of the quantum system with something else. The universe at the quantum level is not made of little billiard balls with definite properties. It is made of something much stranger. What then is this something? One way physicists have learned to think about quantum reality is in terms of fields rather than particles. A field is not a thing in the traditional sense. It is more like a condition of space itself, a pattern of potential that exists everywhere. Consider the electromagnetic field, which permeates all of space. When we talk about a photon, a particle of light, we are really talking about an excitation of this field, a ripple or wave in the underlying electromagnetic pattern. The photon is not a tiny ball of light traveling through space. It is a quantum of energy in the field, a discrete unit of excitation that we can detect and measure, but which does not exist as a separate object apart from the field itself. This field perspective extends to all particles. Electrons are excitations of the electron field. Quarks are excitations of quark fields. What we call matter, what we experience as solid and substantial, emerges from the coordinated behavior of these field excitations. The solidity of a table, the weight of a stone, these arise from electromagnetic forces between atoms, which themselves are manifestations of quantum fields interacting according to specific rules. At no point in this description do we find little hard nuggets of stuff. We find only fields, vibrating and interacting, creating patterns that at larger scales appear to us as objects. But the strangeness goes deeper still. Space itself, the arena in which we imagine things existing, may not be what it seems. In our intuitive picture, space is like a container, a pre-existing stage on which the drama of physical processes unfolds. Objects exist in space, move through space, interact across space. Space is the background, the given, the unchanging framework that makes location and distance meaningful. Yet general relativity, our best theory of gravity, reveals that space is not a passive container, but an active participant in physical processes. Space curves and bends in response to matter and energy. Time dilates and contracts depending on motion and gravitational fields. Space and time together form a unified structure, space-time, which is itself dynamical, changing, and evolving according to the distribution of energy and momentum. This raises a troubling question. If space itself is dynamical, if it can curve and stretch and ripple, what is it that is curving and stretching? What is space made of? The answer, according to our current best theories, is that space is not made of anything more fundamental. Space, or more precisely, space-time, is itself one of the fundamental structures of reality, not something built from smaller pieces. It is not woven from threads or constructed from points. It simply is a geometric structure that encodes relationships between events. Yet even this picture may not be final. There are hints emerging from attempts to reconcile quantum mechanics with general relativity that space-time itself might be emergent, that it might arise from something even more fundamental. In some approaches to quantum gravity, space and time are not basic ingredients of reality, but rather collective phenomena that emerge when we look at deeper quantum structures from a certain perspective. Just as the temperature of a gas emerges from the average motion of countless molecules, without being a property of any individual molecule, space-time might emerge from the collective behavior of some more fundamental quantum entities. If this is true, then the question of what things are made of becomes even more perplexing. Not only are particles not little objects, not only is matter really vibrating fields, but the very stage on which we imagine these fields existing might itself be an approximation, a useful description that works at scales we can observe but breaks down when we probe the deepest levels of reality. The universe would then be something like a hologram, where the apparent three-dimensional structure of space emerges from information encoded in a more fundamental way, perhaps on some distant boundary or in some abstract mathematical space. This brings us to the concept of information, which plays an increasingly central role in how physicists think about reality. In the classical picture, information is something about things. We measure the position of a particle, and we gain information about where it is. The particle has the position, and the information describes it. But in quantum mechanics, and especially in thinking about quantum gravity and black holes, physicists have begun to suspect that information might be more fundamental than the physical objects themselves. Reality might be, at its deepest level, patterns of information, with what we call matter and energy being particular configurations of these patterns. This idea finds support in studies of black holes, those extreme objects whose gravity is so strong that nothing, not even light, can escape once it crosses a certain boundary. According to calculations that combine quantum mechanics with general relativity, the maximum amount of information that can be contained in a region of space is proportional not to the volume of that region, as we might expect, but to the area of its boundary. This is called the holographic principle, and it suggests that the three-dimensional space we perceive is somehow encoded on a two-dimensional surface, much like a hologram encodes a three-dimensional image on a flat piece of film. If true, this means that our perception of three-dimensional reality is, in some deep sense, illusory. The fundamental description of what is happening might be written in a completely different way, without reference to the space we think we inhabit. All of this points toward a conclusion that is difficult to grasp with our ordinary concepts. The universe is not made of things because there are no things in the fundamental description of reality. There are quantum fields, or perhaps more abstract mathematical structures, There are patterns and relationships, symmetries and conservation laws. There is information, somehow encoded in ways we do not yet fully understand. But nowhere in this description do we find the solid, persistent, localized objects that populate our everyday experience. Does this mean that tables and chairs and planets are illusions? Not exactly. These objects are real in the sense that they are stable patterns in the underlying quantum fields. They emerge reliably from the fundamental laws of physics. We can predict their behavior, interact with them, build technologies based on our understanding of them. But they are not fundamental. They are like waves on the ocean. The wave is a real phenomenon. You can surf on it, measure it, predict when it will break. But the wave is not a thing separate from the water. It is a pattern of motion, a temporary configuration that emerges and then dissolves back into the sea. Similarly, the objects we perceive are patterns in quantum fields, temporary configurations that emerge from the quantum vacuum and eventually dissolve back into it. This perspective has profound implications for how we think about existence itself. If reality is made of patterns rather than things, then identity and persistence become far more subtle concepts. What makes something the same object from one moment to the next? In the traditional view, an object persists because it is made of stuff that continues to exist, even if some atoms are exchanged. But if there is no stuff, only patterns, then identity is a matter of continuity of pattern, not continuity of substance. You are not the same collection of atoms you were 7 years ago. Most of the atoms in your body have been replaced through metabolic processes. What persists is the pattern, the organization, the information that defines the structure of your body and brain. This also changes how we think about change and time. In the classical picture, things move through pre-existing time, changing their positions and properties as moments pass. But if time itself is part of a dynamical space-time structure, and if that structure might itself be emergent, then change is not things moving through time, but rather the unfolding of patterns according to fundamental laws. Time is not a river carrying us along. It is a dimension of the pattern itself, one aspect of the total structure of reality. There is something deeply unsettling about this view, and also something liberating. Unsettling because it removes the solid ground we thought we stood on. The universe seems less substantial, less concrete, more like a mathematical abstraction than a physical thing, yet liberating because it reveals that reality is far stranger and more subtle than we imagined. We are not machines made of tiny parts. We are patterns in a quantum field, intricate and temporary manifestations of the fundamental laws of nature. Our thoughts, our consciousness, our sense of self all emerge from these patterns. We are the universe becoming aware of itself, not through the arrangement of things, but through the unfolding of information encoded in the structure of reality. This understanding also has implications for questions about the beginning and end of the universe, about what lies beyond the observable cosmos, about the nature of existence itself. If space and time are emergent, if they arise from more fundamental quantum structures, then the Big Bang might not be the beginning of everything, but rather the beginning of space-time as an approximate description of reality. Something more fundamental might exist beyond or before, in whatever sense those words have meaning, when space-time itself has not yet emerged. Similarly, the heat death of the universe, the far future when all stars have burned out and all matter has decayed, might not be the end of everything, but only the end of the particular phase of reality we can observe and understand. The universe is not made of things because things are a concept that applies to our scale of experience, to the world of medium-sized objects moving at moderate speeds in familiar environments. At the fundamental level, reality is something stranger, something that does not divide neatly into separate objects with definite properties. It is continuous yet quantized, local yet non-local, deterministic yet probabilistic. It is a unified whole, a seamless tapestry of quantum fields and geometric structures from which the appearance of separate things emerges only when we step back and look at large scales, many particles, long times. This does not diminish the wonder of existence. If anything, it deepens it. The fact that the universe appears to us as a collection of things, that our brains construct this picture from sensory data, that the laws of physics allow stable patterns to form and persist long enough for complexity to arise, for life to emerge, for consciousness to develop. All of this becomes even more remarkable when we understand the underlying reality from which it springs. We are not diminished by learning that we are patterns rather than things. We are revealed to be part of something far vaster and more mysterious than we could have imagined. In the end, the statement that the universe is not made of things is an invitation to think differently about reality. It asks us to let go of intuitions built from everyday experience and to embrace the strange and beautiful picture that physics reveals. It reminds us that the universe does not owe us comprehensibility in familiar terms. Reality is what it is, regardless of how comfortable or uncomfortable that makes us. Our task is not to force nature into our preconceptions, but to update our understanding to match what nature shows us. And what nature shows us, when we look carefully enough, is that the solid world of things is a useful fiction, a pattern that emerges from something deeper, something that cannot be captured in the language of objects and properties, something that can only be described in the precise mathematical language of quantum fields and geometric structures, something that remains, even now, partially mysterious, pointing toward deeper truths we have yet to discover.